And welcome back to the Not Lunch session.
No, we're at Module 4.
That's right.
This is Module 4. We're going to cover today... Wait. I saw some comments on the thing, on the comment chat. And so the first question was, where can you get the sample code? I can't believe we have not mentioned this, but it's at xaml.codeplex.com, xaml.codeplex.com. Then I saw more comments. I have the source code, but it won't build. Right under that link, if you just downloaded it, are all the prerequisites. There are 4, maybe 5 things that you have to install, either extensions or frameworks or something like that, all in order to do it. Again, this is a full application. It has all kinds of features in it, so there are lots of things to install in order to enable all of those. It's a great resource for you.
So it's basically RTFM, read the free materials?
Read the free materials.
Yeah.
Right. And, okay, cut to mine, please. So, we're going to go through... I was busy looking at pictures of Norway just now.
Yeah.
And anyway, so... It's a beautiful country. I mean, really it is.
It is.
Something else. It looked like...
Okay, reset the timer to 40.
Probably Photoshopped. I think it's all Photoshopped. All right, so... here's where we've come. Here's where we're going. This is Module 4. Neil's next, just to be clear. So we talked about animations, the responsive design branding. Now we're going to talk about reusable controls in XAML. Absolutely critical, not critical, excellent techniques in XAML. So let's begin. Is everything all right?
Yeah, maybe want to show the slide deck properly.
Like so. There we are. Had that animation that way. So we'll talk first. Yeah, Barry didn't load it right. The custom controls is what the first thing we'll talk about. Then user controls, and then runtime components. Really, all of these are around reusability.
Yeah,
they really
are. Encapsulation.
Yeah, and so that's obviously that's an important just developer concept, but this is how you would do it inside XAML. So we'll begin with custom controls. Custom controls opposed to user controls. So what is a custom control? Yes, what is it? Well, a custom control is, let's see, I remember ASP.NET. Remember, like it's legacy.
Yeah.
Back in the day. Remember Windows 7? Yeah. No, seriously. So what was I talking about? Server controls. They were called server controls. And in fact, I think that's a good kind of corollary if you know anything about ASP.NET development. So
if you don't, just ignore that.
If you don't, then throw that away, right? What is a custom control? A custom control is subclassing of an existing native control. So an existing native control would be the text box, right? And you may want your own text box, and so you can subclass that by inheriting it. It's not sealed, so you can. And from that point forward, your class is a new text box, in this case, a new button in this sample, and it inherits all the functionality of the button, and it allows you to customize it as well. This is a custom control opposed to a user control, and we'll talk about the details.
Absolutely. So but on these custom controls, are we restricted to these high-level controls that are already in place, or can we go further back down the inheritance stack to things like UI elements and the baseline controls and inherit from those?
Yeah, no, you totally can. You can inherit all the way up. You're absolutely right. Of course, if you do that, there's a lot more for you to implement. Right, so the reason you would take button is because you would get all of the events and view states and everything else of the button. However, you're right, you could go all the way up to framework element. But then you've got a lot going on in order to make this final.
Exactly, and it's to a certain extent why items control exists as something you can inherit from if you wish to have the collection behavior, but you want to completely customize how it's rendered, so you don't have to necessarily inherit from, say, list view or something along those lines.
Yeah, that's right, or list view base. That's exactly right. Items control is my favorite control, by the way.
It is.
It really is so useful. I use it everywhere. Anyway, so it's a subclass of an existing control. One of the good positive things about it is because it's subclass, you can retemplate it. So you can do what you can do in XAML. You can set its template property, make it look like anything that you want. Right? All you're really doing is extending its functionality.
So, I mean, one of the interesting things about them as well is, to a certain extent, they're inherently lookless until they have a template. That it's a piece of code that you create.
Yeah, that's exactly right. In fact, it actually brings up, I don't know where here it is, it's the bottom one. So the default style key is important to that. So there's a style already built into the framework for what a text box is supposed to look like, right? You don't need to go get that. If you want to inherit from button and you create my button, now that style will no longer apply to your button. And the reason it won't apply to your button is because the style has a target data template, or a data type, sorry. That target data type goes to button, but your class is now my button, right? And so there's a disconnect. So there's a property on your class called the default style key. It takes a type of type, and basically you say, this is the type of style that I want. And so even though my class name is my button, I want all the styles for button. So you can see in this line, you set this default style key to type of text box. So from this point forward, your button would take the style of the text box. It's going to be great.
That makes very little sense, doesn't it?
wait, I've been waiting for a reason to use. I thought for sure I had the marker.
Stay on target.
I just wanted to exit out. And anyway, so as you can see, right there is the stupidity that it should actually say button. That would make sure that my button uses the style of all the buttons. And just because I'm subclassing it, I don't lose the benefit of all of that rich styling that I want. Maybe all I want is to add, in this case, like a watermark or something. And so...
Because you want that on your button.
This whole thing, this whole example is messed up. Because look at the style below. It's a text box style.
Exactly.
Well, I mean, it is all it would work.
It would work.
It'd just be
Apart
stupid.
from your application. Other than that, everything would work.
Yeah. All right. Great. So let's go to the next slide because I'm getting.
I think it's demo time.
Yeah. Let's show okay. This is a custom control. It's inheriting from the existing control. All right. Let's see how we've done it in our app. So
and we won't be showing a button that's inheriting from a text box.
That's right. All right, so I'm going to run the app. This is the app as you would have expected it to run, and just about there. Still orange from the last time I changed the color.
Yeah.
I dig the
Are
orange.
you saving some settings there, perhaps?
I am. Yes, that's right. Local settings. We'll talk about that shortly. And anyway, so there's no navigation except away from the home or the hub here. And so if I select this first one, let's say, now I've got this back button. And this back button is the same every single page that I would go to. If I go to another page, it's just the repeating logic of going back and going back. There's a little bit of testing to make sure you don't go back when you're not supposed to and stuff like that. That logic needs to be encapsulated so that I only have to write it once, and then I want to reuse it over and over again in all of the different pages. And so let's look at how I make the back button. The back button is right here in controls, called back button, and wholly easy.
Mm-hmm.
I mean, look at that.
Yeah.
I mean, that is just fantastic. All right. Anyway, this is it. There is no XAML to this, right? I think that's important because we're inheriting from button, but all the styling is handled somewhere else. And so there is no XAML to this. I can't do a Shift F7 to see what it looks like. I'm not initializing, right? I'm just inheriting from button. And so I do two things. First thing I say is the default style key is this.getType. All right, so that's saying the default style key is itself. And this is really an explicit way of saying what would have been defaulted otherwise, to say this is the back button, and now styles for the regular button, I don't want them. I want styles for the back button, and then we'll show you how we set those up. And then the other piece is just the click. I want that click event to go back, and then so that the logic isn't repeated, I can have it here inside this control. And from this point forward, watch this. If I go to, let me stop debugging. If I go to, let's say, the splash, which would be a funny place to have a back button, I can go into my toolbox, and at the top here, there's the back button. So it shows up just like when I build a user control. It shows up right there. It's a custom control and allows me to drag on and use it. In fact, I could even use it on the same page several times.
Whilst we're actually showing this, I think this is the first time we've shown the design view of the splash page. You can see that the image is located up the top left, and this is where that reposition logic is used from the core splash screen class to actually position that in the center and size it appropriately.
Yeah, you're right. If you didn't see this, you might have assumed that we had just centered it.
Yeah.
But centered, it doesn't work.
It doesn't work.
I mean, it will center it, but it won't match the splash. The splash is a little off.
Correct.
I wonder which is off, the splash or this. Huh, that's interesting. Okay, anyway, so it shows up in your toolbox just like anything else. And but then let me show you inside our styles. So I have our styles folder here. I'll open up standard styles and jump to the bottom, just where I've got it laid out. Where I've got it laid. Where do I have it laid out? Oh, here we go again. The back button style. Maybe it's under custom style. Maybe it's in app XAML. Doggone it.
Do Control-Shift-F and search for the name.
That's a great idea. What's the name? Back button. There it is. Look at that. Yeah. That's not it, by the way. That's my back button style. Hang on. That's the one that comes with it. There it is. No, still don't have it. Dag snag it. All right, this is it right here. Look, line 1,547.
I can't believe you didn't remember that.
It's harder than you thought to scroll to. All right. So you can see that its target type is not the regular button, but instead it's the controls namespace, which is where we have it, and the back button that we've created. Now, it does inherit, so it's based on the back button style. That makes it look the same as a regular back button that comes free in the standard styles that you get with a project. And then we just do a couple extra things, change the margin and make sure it's aligned to the right spot. So now whenever I drag this onto a page, it's going to be in the correct spot, always uniform in the same place. It's also going to have the same reusable functionality, and I know they're always going to be the same.
Yep.
The way your app works might be different than the way ours app works. Your back button might need to do something different, but you can still encapsulate it just like this.
Yep.
So this is not a user control. It is an encapsulation of code. It is reusable code, but it's different than a user control. It is I forgot the name. It's a custom control. Golly.
Exactly.
I am so hungry, I guess.
I know. You're lightheaded.
It is, yeah. Here,
Empty-headed.
This will help. All right, I'm better. All right, so let's talk a little bit about user. Seriously though, let's talk a little bit about user controls. Transition now to user controls.
Yeah. For Jeff.
User controls there's a contrast between custom controls and user controls. First one, I think most importantly, is it cannot be templated, right? I mean, what you lay out is what it is. This is a container of layout information, basically.
So you're really encapsulating the XAML and your code behind.
That's exactly right. Where we didn't have XAML before, we certainly have XAML now. In fact, if you think about it, where we had the style only to give it a look and feel, you could put that in all of your different styles, make sure your back button looks different in every type of theme that you have. This is where you're saying, this is the way I want it to be laid out. It's meant to be whatever, right?
Yeah.
So in this case, you can see it's a user control is the outer container. It's the type that it inherits from. And so this is my control. It has a grid, text block, and text box. You can put anything that you want in this. And it's kind of it's a reusable container as well. You can also implement panel if you needed to, so that you could have a user control that you put things inside of as well.
I think it's fair to say probably the most common use for the user controls is actually grouping together multiple controls. That you're going to place multiple controls and create a layout that's going to contain those controls. So whereas a custom control generally is extending an existing single control, a user control is a chunk of layout that you're going to reuse across a number of different pages, and that generally contains multiple controls.
That's really your goal. I mean, since you're not inheriting another control, you're implementing everything now. I mean, the user control gives you a little bit, but you don't have all the button events and all the button whatevers, right? You don't have anything. Now it's up to you to do all that custom implementation completely.
Yes.
And sometimes that's great, right? Because a user control usually is a simpler thing. You know, that's just kind of the way it goes down to it. You still get that encapsulation, you still get that reusability, but you have more work. But it's really about layout, really about the composition of it all.
Yes.
There's kind of a gotcha here for developers. This would be a common scenario. I create a user control. Let's say inside it, just like this, I create a text block and a text box, and that's it. And I want to bind to that text box. So I would drag in my user control. And I would say, and let's say I'll create a property, of course, called text. That would correlate to this text box.text. And I would bind from the parent that's using it to text binding and whatever that value is. You would think that would work, right? You would think that you could bind directly to, even if it was iNotify property change, it will not work. That is not how you bind to a property inside a user control. Instead, it absolutely must be a dependency property. The only thing, in fact, just take this away. The only thing you can bind to in a user control is a dependency property of that user control. You cannot bind to a CLR property, period. And then you can use the on value changed the changed event
on property value changed.
on property value changed event of the dependency property to marshal back to the user control and write the property in however you want.
Absolutely. I mean, generally you would create a CLR property facade for interacting with those values from the instance of your control in the code behind.
Yeah, that's exactly right.
Yeah.
Yeah.
Get and set values. And
just
so on
like the other kind of caveats we've been talking about, this does not result in an error.
Yeah.
It just results in a not work. Right?
Yeah.
And you pulling your hair out for trying to figure it all out.
And actually, we did a tweet chat the other week, and we got some questions around binding and how do you debug binding and so on and so forth. There's a couple of places where you can look for that. If you've got a binding that just does not work and is an invalid property name and so on, that's generally listed in your console output when you run up the application, invalid binding expression and so on. If, however, you bound to something like this, where it's completely silent failure and you're just not seeing what's going on, another strategy that we talked about is creating a custom value converter.
Yeah.
And the value converter isn't actually doing anything to the value itself, it's just passing it through, but it gives the opportunity to intercept during a binding evaluation to actually see what values are being set. So you can turn around and say, oh, I'm being passed null, or I thought it was going to be a string, but it's actually a URI type that's coming through, and so on and so forth. So that's a handy tip, because right now we don't have the ability to debug binding expressions is the way that you could do in Silverlight and WPF.
Yeah. In Silverlight.
Yeah, true, Silverlight.
For sure. The on that though, yeah, it seems crazy to use a debug converter just with a debug breakpoint in it. But there are times that's the only option you have as a developer to be able to look at the context of the binding.
Yeah.
Especially if the binding is like inside a repeater as well, and you're like, I don't even know how to get this.
Where the heck's going?
There is no .write or anything. I mean,
No.
I guess you could put it in the, but you still have it. Yeah.
Yeah.
That's a good trick. It's a good trick. I do it not all the time, but I certainly do it regularly.
Yeah, I have a little library of them that I use.
Yeah. Yeah. Okay, so let's look at this app for just a second, and I'll show you what we can do with the user control. So again, it's a lot like a custom control because you want to reuse it. And so in this case, this application has logged me in through my Microsoft account, and so I'm Mr. Microsoft, right? So we're logged in. That's not my personal account, just so you know.
Now that's what you like to call yourself, isn't it?
Yeah, Mr. Microsoft. I'll tell you what you can call me. And so it's a nice little badge. We call this the badge right here. It's got my name, it's got my email address, and it's got my picture. That's nice. And I might put that all throughout my application so that I can see who's logged in. In fact, if I were to open up the details page right now, I would see that the details view does not have the badge. So here's how we would reuse the badge, right? So I can go in, and just like before, if I go to the toolbox, there's the badge, and I can drag it into my application, and if I move it down, oh no, that's the right place for it, good. If I, then should I not have, right there, I can't select because it's blank. Wait, I'm going to drag it in again, like so. All right. No, wrong freaking one.
This is what happens every time you go off the reservation.
All right. All right, so now I have it here as well as on the App Hub. Each one now is using the same logic behind the scenes. I don't have to interact with this at all from the point of view of the page, because they run independently. They have their own loaded event. They have their own pipeline that they can work through as well. You can talk to them through their properties. You can talk to them through their methods, but you don't have to. They can be completely isolated like this one is. Mm-hmm. Yeah, it's very nice. Now, if I were to show you the code itself, it is in controls called badge, right? I mean, it's as simple as you can imagine, right? It's just a little grid with an image here and two text boxes. And look how I've made the user control itself is transparent, and that's why we couldn't see it when I was dragging it on. But that's kind of by design. You want it to be able to put it anywhere and not have to match what you
blend into whatever you're using it on.
Yeah, that's exactly right. And so transparency is important. And it's really simple. And probably it's the XAML and the layout here that matters the most, right? Just so it's uniform no matter where you use it is the idea. It has its own code behind. Here's the code behind. Doesn't matter what this one does. Just know that it has its own pipeline that it works through and can handle itself completely independently. You can do caching or whatever developers can dream up. Yeah, honestly.
And this is a lot easier to create than trying to create a custom control that has all the template parts, has its own generic .xaml in the theme subfolder, and so on and so forth, because you can create this kind of experience with a custom control, but it's a lot more work, which is really why the user control's there.
So from a best practices, no, this would be more from a warning point of view.
Yeah.
So I think a lot of developers are tempted to create a lot of user controls when they see repeating things, when what they need to be creating is a data template.
Yeah.
Often they'll see like, oh, I'm repeating this inside my list or my whatever, and that's time for a data template. And it's weird to keep all these kind of together. There's so many ways to encapsulate.
Yes.
Of course, a data template is pure layout. No logic at all. It's just how is the XAML supposed to be. A user control is the combination of layout with code
behavior
behind as well.
Exactly, and so it's a much heavier weight component. And so if you've got list views and so on and so forth, if you're creating all of these user controls, your memory footprint is much higher.
That's right. A data template is very lean. A user control is lean. Not as lean as a data template.
Exactly.
Yeah, exactly. All right, so that's a user control, right? Interacts just like building a page, only little, and you get to put it on pages, right? And then, by contrast, a custom control. Perfect. That's how we do the user badge. It's a user control.
Yep.
And then there's another way we can reuse. So we talked about templates, we talked about styles, we talked about custom controls, we talked about user controls, and there's one more way.
Yep. WinMD.
WinMD, Windows Runtime Components. Special to Windows 8. We've never seen this before.
WinMD, Windows Metadata.
Windows Metadata, the MD. That's exactly right. Exactly. It's not meant for doctors.
Not me. But doctors can use it.
We only play one on TV.
Yeah.
All right. So special about Windows Runtime Components.
Absolutely. So the key thing about a Windows Runtime Component is it can be shared across all the languages with which you can develop Windows Store application programs. And so you can create something in C# that could be consumed by a C++ program, or in fact by a JavaScript program.
That's awesome. So you can create something in C# that's used by JavaScript.
Yes.
That's awesome.
You can create something in C++ that's used in C# and JavaScript.
Yeah, and I can create something in JavaScript, but it can only be used in JavaScript.
Yes, you can't create a WinMD component in JavaScript. Yeah. Some would say that's unfortunate. I say, ha, ha, ha.
Hey, this is advanced using C#,
exactly.
not using JavaScript.
Exactly.
A little shout out to Jeremy Foster. Trapped in JavaScript.
Exactly. So, but with this cross-platform goodness comes constraints.
That's right. If you're going to cross all these languages, you can't start doing .NET stuff in JavaScript.
Yeah, you have to basically use the lowest common denominator, and the lowest common denominator is the Windows runtime types. Those are the things that JavaScript, C#, and C++, and Visual Basic understand, and so that can cross the boundaries between those various layers.
Well, that not so much that they understand them as much as, I mean, not to correct you, of course, right? But is that the runtime translates those types up into that language and what they expect. So
has the ability to marshal them.
Yeah, that's right. So C# is looking for .NET types. They see it as a .NET type. C++ doesn't understand .NET types. They don't see it as .NET types. They see it as the types they expect.
It's effectively the projection mechanism that leverages the metadata that these components expose, and then each language environment understands how to take those projections and map them to their inherent types.
So we've listed all, there's quite a few here. We don't have to list them all, or go through them. One of them would be a generic, right? Generic is specific to .NET, right? If you hand a generic off to JavaScript, its head explodes, right? It doesn't know what to do with generic. So there are certain limitations of very unique types or approaches in certain languages. You can't do that. You can do what the runtime understands, because the runtime is that common denominator.
Yep, and so it also follows that you can't have anything that's public that you expect to share across these boundaries that don't inherit from those runtime types.
Right. You can't inherit from a .NET class and then pass that off to C#
Yeah, it's not going to know what to do with it. Also, your public interfaces, You can't just create a public interface that only means something to your application and your environment. That's not going to be something that's going to be globally understood. So it has to be an interface that inherits from an underlying base Windows runtime type.
Even your naming conventions are slightly constrained. You got to make sure you match the name of your assembly, and you don't try and weasel your way into the Windows namespace.
Yeah, and then I think there's a couple of these security restrictions, if you like, which is your namespace must represent your assembly. It has to be named for your assembly so that you can't pass yourself off as somebody else.
Yeah.
And equally, you also can't have a namespace that begins with Windows, so you can't try and pretend to a consumer that it's part of the Windows namespace.
Yeah, that's right.
So again,
it's tricky.
A little bit of security and so on and so forth.
So let's see it. I think remember we did a demo in our first day.
Yeah.
Where we showed a WinMD. We wrote it in C#. Saved it out.
You used a really complex algorithm, if I recall.
Yeah, I think I even did it from scratch.
Yeah,
right?
yeah.
I do
was it 1 + 1?
It was dynamic. You could do lots of numbers, and we ran that in JavaScript.
Yeah.
But we were always saying you could also write it in C++ and use that in whatever. So let's show a demo using a WinMD control, a Windows runtime control.
Absolutely. So
written in C++.
if we look at my desktop environment, what we have here on the right-hand side is we actually have a C++ assembly. That's part of this library. And the way that we created that was File, New, Project. And we can specify other languages, Visual C++, Windows Store, and then we have Windows Runtime Component. And so that will create a project with all of the necessary references to external components and apply the right settings to the compiler and so on and so forth. So that was how that was created.
And it knows how to constrain you. So if you start violating these rules that we talked about, it tells you.
Absolutely. And so this is what the class looks like. And I didn't write this. This came down from MSDN. So there is a sample out there that shows how to create these applications and these components that you can reuse. But basically, this is a C++ class that calculates prime numbers.
Nice.
Now, the key thing about this class is not only is it using your standard kind of C++-based header imports and libs and so on and so forth, it's also accessing namespaces. So this is managed C++. It's accessing some of the managed resources that are part of the primary foundation. Yeah. This is the implementation file, so this is where we've implemented a bunch of algorithms.
Yeah.
And we're actually using asynchronous operations, and we're actually using callbacks, so we can push progress back into any consumer of this framework.
Since you have it open, go to the signature there. So see that little hat next to integer? Yep. I think that's worth pointing out so this is C++ CX. This is the extended version of C++ meant for Windows 8 development. That little hat indicates a reference, so that it's not a garbage collection, but it kind of works like garbage collection, so you don't have to maintain pointers. A lot of not a lot, there's some small syntactical changes that make C++ a little more approachable in the Windows 8 environment.
Yeah, if you're familiar with iOS development as an example, in early versions of iOS, you had to manage your own memory allocations, malloc and free, and so on. In the later versions, they introduced reference counting so that they could manage your memory for you. And this is a similar approach inside the Windows environment.
I cannot imagine a better example. All right, go ahead.
So basically, we have these algorithms that are using Parallel 4, so it's analogous to the parallel task library that exists within the C# world. The really interesting thing about this particular class is it's actually using a library that allows you to delegate these things to the GPU. So because we're doing math calculations and GPUs are incredibly competent at math calculations, the C++ library is actually pushing this out to the GPU and offloading a lot of the calculations. So it's using things like interlocked increment to ensure that these things are running on a single process, so we can push back progress bar updates and so on and so forth.
Pause just for a second. I just have to appreciate looking at this as a C# developer, how non-intimidating C++ is as a C# developer, right? I think a lot of us don't. We expect it to be unapproachable when it really is more than it is. Like interlock increment, we have that in the .NET framework as well. And these things are familiar to us, and it's just a subtle change in syntax.
Yeah, I mean, they all come from a common root, the C language. One of the key things that I think is differentiated in C++ is any method name is prefixed by the class.
Yeah.
And so, again, it's just a convention you have to accept once you get used to it.
You get used to colon.
Yeah, it's certainly a lot better than objectionable C, that's for sure. That's a pretty tough one to actually get your head around. So anyway, that's that. I'm not going to spend much time going through what this does, other than this is a component that is expressed and exposing a WinMD metadata.
And it returns prime numbers.
And returns prime numbers. So how do we integrate that with a C# application?
Yeah, how do we do that?
Well, it's simple as adding a reference. Because if we look at the solution, we can see that it just appears as a reference in the solution.
Sure, it doesn't know that it's C++. I mean, it may know, but it doesn't care that it's C++.
It doesn't care. We can mix all of these languages within a single solution.
That's pretty important, because you may have already spent and invested in C++ assets because of other platforms, because of Windows 7, because of who knows what. And now that's available to you again. Now you can take those same assets, bring them in, compile them now as a WinMD. So there may be a tweak or two.
Yeah,
in
you
order
may need
to
to create a facade around it to encapsulate the behaviors and use Win runtime types to expose out those results.
And you can even use it if you've decided to make your application an HTML5 Windows 8 app. Fine, you can still use your C++ resources.
I mean, you're not having to work in things like with PhoneGap, where you've got these bridges between your JavaScript environment and so on. That bridge is already there for you as part of these Windows Store applications. That marshals all of these things backwards and forwards in a very efficient way. I mean, that's the whole part of this, the language projection, the type projection that's built into this framework.
Yeah.
It's incredibly powerful. So that said, we've added a reference to our C# library to C++ mathlib. So how do we actually leverage it? Well, we can just use it as if it was a native part of our library. So here we're actually creating, or we're referencing our mathlib, and we're creating an instance of prime calc.
Beautiful.
And we now have a native object. We can call it whatever we like. We don't have to call it native object. And we can see that the var is of that type, so it's strongly typed. This is not dynamic. This is not com, in that we've got something that's an object sitting around. This is a strongly typed element that we know what it can do. So if I just type native object dot, I have IntelliSense.
Yeah.
And I can see everything that it does.
I think this is also important, that from this point forward, interacting with this C++ library, it's just going to return numbers to us. But no matter what it is, it's .NET types that we see. And the C++ developer didn't have to do that. It just is being translated and projected into C# as .NET types.
Yeah. And so here we're calling a synchronous method that computes a particular result. And we can see IntelliSense tells us we're going to get an interface list of type double returned back to us.
Yeah.
And so that's what val is. And we can iterate through that as if it was just something that came in our own code.
Yeah, that's nice. It really is.
Same down here, where this time we were actually going to interact with something as an asynchronous method. So this is declared as an asynchronous method. We have async up here. We're not doing a wait. And then we're setting up some handlers. So as this falls through, we set up the handler that on the progress event, we're supplying a callback, which is going to update a progress bar. We're going to wait async for this so that we get the results back.
Oh, that's because it's calculating these prime numbers. It takes time.
It takes time. We're using async and await so that our UI remains responsive, because we don't want it to lock up.
Especially not in a demo.
Exactly. That would be unfortunate. That would be something Jerry would do. Then basically we're converting the results back. And
listen to Barry over there chuckling.
Exactly.
Shut the front door.
And so let's just run this application up. So as we can see, I indeed am not a designer either. And this is the UI. And so if we hit the synchronous one, we see that this responds back immediately. And so we can see that there's no kind of spool up going on. It's not as if we're creating a new container that's going to be running this application and so on and so forth. It was instantaneous.
Some main or whatever. It's in there. Yeah.
So now we're going to go out and generate a whole bunch of prime numbers. I think between 2 and 100,000 is what we're iterating through.
I'm going to get a pin and see if I can beat it.
And so, so here what we see is the power of C++ and offloading these calculations to the GPU.
Yeah,
'Cause
that's serious.
That's a lot of values that have just been generated in a very short period of time.
Seems fast. Must be easy.
Yeah, it must be easy. So again, if we do it unordered and we're getting progress bar and we're updating,
Still
again,
fast.
that comes back pretty darn fast.
Yeah, yeah.
So now I actually did an implementation of the algorithm somewhat similarly for C#. I'm using an asynchronous task to do this. And we can see that it's a little bit
Come on, baby,
slower.
Go! Go!
It's not going to make it. Oh, I made it. In fact, she was giving it all that she could go.
Nice. Had I only been ready.
Exactly. And so, but that gives us an example of really the power of reuse, that C++ integrating into the infrastructure such as the GPU is going to number crunch a lot faster than managed code.
Yeah, that's pretty cool.
You can see it outright here. So if you've got these high-performance calculation engines that are out there, you can incorporate them into your managed environment, into your C# applications, and do a heck of a lot of very powerful number crunching. It really, really shows the power of this capability.
Yeah, that's pretty neat. So we're talking about reuse in this module. We're talking about creating custom controls that's inheriting from those native controls that are already there. You get all of their functionality, but you're able to override and kind of customize that implementation to match you. You still can have the benefit of their style, or by using that default style key, you can start pulling from other styles or a custom style. Then you have user controls where you control all the layout. There's XAML in this one where there isn't in custom controls. They can't be retemplated because your XAML is the template. Then you can also have that code behind to make that user control have the implementation you want. There's almost no functionality in a user control until you build it. But sometimes that's perfect. That helps them also to be very lean. And we talked about not confusing those with a data template, which is UI only and doesn't have that code behind.
And then we talked about Windows runtime components and how we can encapsulate business logic and into these objects that could be shared across all the various languages supported in the App Store environment. We also mentioned that there are a few restrictions on those, such as you can't create them in JavaScript to share across. But other than that, it's a very, very powerful.
And it's a neat way to reuse assets you've probably already invested in, depending on what you've done. And it's a neat way to leverage your team. You may have quite a few C++ developers. You may have quite a few C# developers. Maybe you have some HTML developers. Everybody can have a role in the project.
Absolutely.
Yeah, pretty nice. Can we go to lunch?
Yeah, I think we should.
Okay, just making sure.
Yeah, I think this is Module 4. We've completed Module 4. We're now going to break for lunch.
Perfect.
And we'll come back.
And we'll break for lunch. How long, Barry?
1 hour.
1 hour. We'll see you in 60 minutes.